Welcome back to Think Design Work Smart. I'm Alex Bolbaka and I'm coming at you from the Mosaic Work Studios, and what I have for you today is a deep dive into modular monolith, one style of software architecture that I feel is not discussed in enough detail, at least not in the details that I'm going to try to provide here or from this perspective. So I believe it will be very interesting. Even if you are not using monoliths, I think it's a good idea to remind ourselves that there are various architecture styles with their advantages and disadvantages. And as software architects, we need to be able to look at these architectural styles to figure out the trade-offs, where they apply and whether they fit in various parts of our architecture. I feel I have this intuition based on my past in software development, based on my time spent in the industry, that we are up for a shake-up in software architecture. I think we will change some things. Microservices has been around for a long time in terms of software architecture, and we already saw cell architecture as an alternative, but I believe we'll start seeing more variation in software architecture depending on what we are trying to build, particularly with the pressure of AI currently happening. So this is what we will do. Now, before we move on, I'd like to ask you a quick favor. Like, share, subscribe, maybe leave us a comment. It's really great to see comments from you and to engage with you. But we are also very close to 800 subscribers, so it would be really cool to reach this level of subscriptions. I would really enjoy that. And a quick programming note for next week. I have planned a live stream on architectural kata. So I'll perform an architectural kata with whoever joins me, and we can have, if you engage me in chat, we can have some conversations for a couple of hours roughly. All right, that's it for now. Let's move on with our modular monolith. So first of all, I think that modular monoliths are kind of a mythical beast in software architecture. They sound simple enough, but it's like we don't see them. They sound simple because what's a modular monolith? Well, it's a monolith that is composed out of modules. Sounds simple. A monolith is a unit that deploys as a single unit. So examples of monoliths would be your mobile applications, your desktop applications, if you still do those, particularly when they don't, well, or at least the part that runs on the desktop. And even your React applications are actually monoliths, right? They call an API from the server. It's more of a client-server model, but they are a single deployable unit. Usually, in the past, we used to have not full monolith. So full monolith would be an application that includes its database engine. You can do that with SQLite, for example, but it's not something that I see many applications doing. Maybe some, well, actually many mobile applications are doing something like this. But usually what you have is the monolith on one side, and then you have storage, or in many cases, some kind of server on the other side. And this storage would have been a separate entity, usually a server, a database server. So what does it mean to be modular? Well, it means to split the architecture into parts that can modify separately and don't affect each other as much as possible. Now, of course, there are a lot of conversations here because there are lots of ways of having dependencies in software, and some of them are logical. So of course you would expect modules to behave in a certain way in order to provide the necessary responsibility for other modules, or to build up a more complicated and interesting functionality. But the basic idea is that you have these things that are separate, they can modify separately, and even we can go as far as saying as maybe modules should be replaceable. The example I like to give is the example from IKEA furniture. If you go to their and look into how IKEA furniture is built, it's built out of modules. So you can configure your various pieces of furniture from IKEA into various ways, and then replace some of them, and still, as a whole, it will function. It will have the same functionality, but it will be a different implementation, let's say. So in order to have modules, we need a few things. We need clear responsibilities. And those responsibilities are it's usually best to define them as a contract, and even better to define them as contract tests. So you write a set of automated tests that define the contract. And the contract is not only what the component is doing, what the module is doing, but also how it interacts with the other modules. For example, does it use synchronous calls, asynchronous calls? Do you need to call multiple methods from the API in order to achieve something, or a single method? Things like that. So these are the contracts. And it needs to have an API. And I want to say here one important thing is this API has to be intentional, has to be designed. So when you think about a module, you should also have a vision on how the API of the module will look like and how it will interact with the outside world. Now, how you design it, you can design it in various ways. You can design it by drawing diagrams. You can design it by using REST API principles, or you can design it through an evolutionary method like test-driven development. That's perfectly fine. But it's important to have an intentional interface, one that is designed, because otherwise what happens is that it won't have its own identity in reality. It will just melt down as the software evolves. And I think one very important part is to have a hard boundary. So a hard boundary between modules means that ideally you are not able to call the insides of a module. You have to go through the API of the module in order to get to the inside. Unfortunately, these hard boundaries didn't exist for a very long time in software. And my feeling is that we ended up with microservices because they do provide this hard boundary for modules. What we really wanted was modules, but the only good implementation we had for modules is through HTTP-based APIs that provide a hard boundary. So now that we understand what the modular monolith is, let's talk about the process of getting to design a modular monolith. You would start by identifying, by understanding the problem, of course, but then you want to identify modules. And the leading technique for identifying modules right now is domain-driven design. In particular, there are two techniques domain modeling or event storming. These two techniques can provide you with ways of separating a large problem into modules. And now how domain-driven design is operating is mostly by assuming that there is a core domain that tends to change slower because it's something that's the substrate of the application. It's what we are automating. It's something that exists before we write the application. So therefore, it had some time to evolve and to get stable, which means that it changes slowly. And because of this, we want to identify this domain, model it into smaller parts that are changing with different speeds, or that are or that can be disconnected from each other. And then we design our modules around these domains or subdomains or bounded contexts, as they are called in domain-driven design. But this is not the only way of decomposing systems, and if you want to learn more, you should go and read Parnas's paper, seminal paper on the criteria to decompose systems, something like that. It's a well-known paper. But we can imagine right now that what we are doing is domain-driven design, domain modeling, something that maybe you're familiar with if you're doing microservices, because we are using the same technique there. Or you should. If you're not, then that might be one of the reasons why you have problems with your microservice architecture. So now we have obtained the conceptual models. We need to design their APIs, right, and their contracts, and figure out precisely what responsibilities do they have, how do they interact with the outside world. And the outside world is, in this case, okay, they will be part of a monolith. So, but the outside world for a module is everything that is not that module, even if it's deployed in the same unit. So we need to be very careful with terms here. So now the next question is, how do you deploy this? Well, obviously you deploy them as part of a single unit, which means that we have a few ways of separating our modules inside this simple unit. One of the simplest ones is using namespaces and the Façade. So imagine you have a namespace for, what would you say? So imagine we are doing an e-commerce application and you are ordering stuff. So maybe you have a bounded context and a module for orders, and then you would have a namespace that separates everything that relates to orders. And in front of that namespace, you place a Façade class. And that Façade class serves as the API for the module. Now, the problem with this technique, this is a very simple technique. It can be easily implemented. It can be easily tested. You know, you have a lot of advantages here. It's supported in all programming languages. The challenge is that this does not stop people from calling the insides of the module. And I'm going to go back to this because there are ways to deal with this in practice, architectural tests. The second way of doing this is to use native modules present in the language. More and more programming languages have adopted modules. And you can now define modules in, I think, Java, C++, I think it's either possible or coming, and so on. So maybe you can do this instead, but still compile it and, well, deploy it as a single unit. Now there's still some way to go here. I haven't seen a lot of interest in these techniques. They seem to be very cumbersome still. But if you have any experience with that, I'd be interested in hearing. So let me know in the comments. The third way of doing this is if you have a model view controller style application, whether it's web or desktop, it doesn't matter. One way to separate modules is based on the request. So imagine you have, it's easier to explain this with a REST API MVC type application, where you get a certain structure of the request. So maybe you'll get /order, and that connects to the order controller that can then go and call everything else that is within the module. So in this case, the order controller serves as the API for your order module, which is deployed inside a larger monolith. Once again, the problem here is that nothing is stopping objects in this module or code in this module, in the order module, from calling code from other modules directly. What we should do in this case is to figure out a way to send calls through the controller or through some kind of an event system that is inside this internal to the MVC application. And then you raise an event and other modules are responding to that event and so on. Think of it as an internal RabbitMQ or event bus. So once again, how do we prevent this from happening? Well, we need to use architectural tests and discipline. These are the ways to do that. Third way is to use some form of hexagonal architecture. Now, hexagonal architecture doesn't necessarily state that you split things in modules, but it definitely gives us a way of doing that because it separates the core domain from the outside world. And then the core domain, you can split it into modules with one of the techniques that we discussed. People also talk about clean architecture, which was heavily popularized by Robert C. Martin, by Uncle Bob. But to me, clean architecture is a more complicated variation of hexagonal architecture. I understand why people like it because it's easier to start with it. But honestly, I would rather have you, if you're looking at clean architecture, try to understand hexagonal architecture. I think it's a better fit for most of the problems that clean architecture is trying to solve. And in my mind, at least, it's simpler. Yeah, you still need to figure out some implementation details, but it's really, it feels simpler. At least that's my perspective. So this would be another one. Again, you need to figure out a way to separate modules. So this doesn't necessarily solve all the problems here. Another very interesting one is to use the actor model. So the actor model is a framework or a way of writing code that uses parallelism inside your monolith. And the way it does it is by representing your objects. So instead of having objects, you have actors, and those actors are basically threads, right? But there is an easy way to communicate between these threads. This is a pretty, let's say, far away from the usual style of monolith, but it's a really good way of experimenting with microservices without actually writing microservices, and to be ready to split into microservices easier, because you already have this, you'll already face a bunch of issues that you normally face when switching from a monolith to microservices with this actor model, but without the additional complication of deploying a lot of different units, right? So it's a really interesting way of writing code, and you can see it as an actor will be one of module, and then the API is the messaging interface for each actor. If you'll be looking at actor model frameworks like Akka, or there are a few for C++. All right, so these are some ways of deploying modules inside of a modular monolith. Now, how do we maintain the integrity of this architecture? Well, I already mentioned one way, which is automated, and that is by writing architectural tests. Architectural tests are tests that you can write and that enforce certain constraints on the architecture. And one of the constraints that you can enforce is the orders module cannot call inside objects from the inside of another namespace, for example, or classes from the orders namespace cannot call classes from the, which one would be, shopping cart namespace, or from the invoicing namespace directly. They need to call the Façade. So these are tests that you can write. There are tools that support this, and you can run them as part of your continuous integration. And this would allow you to introduce certain constraints into your architecture. The second way is the manual way, which is reviews and guidelines. I believe that it's not possible to do only one. It's possible to automate up to a point, but then the rest is about discipline. It's about guidelines, reviews, things like that. There will always be the temptation to skip one of these rules just in order to deliver a feature faster. But once you go that, it's a slippery slope. You will soon end up with a mess if you don't immediately correct. So yeah, architects need to look at the code, need to write guidelines, need to do architectural reviews. Absolutely. Now, let's talk a little bit about advantages, disadvantages, and things to be careful about. In terms of the advantages, a modular monolith is easier to split into services, or if you need to scale up parts of the monolith faster than others, it's easier to extract this. It's not 100% simple, because it's one thing to have in-process calls. It's a completely different thing to have out-of-process calls, whether they are HTTP or through protobuf or through some kind of process calls. So it's not 100% easy, but it's easier because you already have the structure. And if you follow the rules, you can extract the module. You could also replace the module, right, with an implementation that uses an outside library, for example, or an outside API. And of course, there will be some adjustments there, because you might increase the latency. Some parts of your code might not expect that increased latency, and so on. So you end up with a bunch of issues, but it's generally easier to split because you don't have to do the logical part that's already done. You move the code to another place, add and modify the API, deploy it, and then deal with the communication. It's simple to deploy. It's a single unit. You package that, you compile it, you deploy it. It's also a natural way to develop because it's easy to navigate, to figure out where things are, and so on. Can take advantage of refactoring tools in your IDE when you have everything in one monolith. What are some disadvantages? Well, a disadvantage is scalability. This obviously scales as a whole monolith. It cannot scale as parts of it like we do in microservices. We either start 10 instances of the monolith or 4 instances of the monolith. We cannot just scale the ordering module. In order to do that, we need to extract it. It requires discipline. Even if you have architectural tests, well, first you need the discipline to write those architectural tests. Second, developers need to maintain the discipline of following the architectural tests results. It's easy to just ignore them, right? Or temporarily suspend them from your continuous integration. There are all kinds of ways of dealing with that. You could use reflection to call, and that would not be caught by architectural tests. So there are all kinds of ways you can avoid these rules. So really the answer is discipline. Another challenge is that it's easy to mix the core domain with UI and storage because of this structure. This is where things like hexagonal architecture helps, because if you start with hexagonal architecture and then split into modules the core domain, hexagonal architecture gives you the way of separating UI from and the outside world from your core domain, and it's really good way of dealing with it. All right. So what do we need to be careful about? It can devolve. It can devolve into spaghetti code. It can devolve into a big ball of mud. It can devolve pretty quickly. And as I said, it requires discipline, which is difficult to maintain and enforce over longer periods of time. But overall, modular monoliths, they are quite interesting. They can be useful in many situations. You can solve a lot of problems by adopting this style. It's not free. You always have trade-offs in architecture, and you have trade-offs for modular monoliths as well. But maybe if you start a new product, you could start with the modular monolith instead of jumping straight to microservices until you figure out what is the product market fit, and then you can scale the different things and extract the different things that scale separately, incrementally as needed. So to me, that's a really good way of looking at it. It's like an evolving architecture that gives you options. You create options from the way you are structuring it in the beginning, but it gives you options as your business grows. And that's a really good way of doing architecture. But on the other hand, yeah, it requires some discipline, and some of these things are quite foreign to people. Like maybe even the facade pattern, it's not as obvious. on how to use for this particular context. Anyway, this was my take on modular monoliths. If you want me to talk about other architectural styles, let me know. Which one do you find interesting? Let me know in the comments. Let me also know what are some of the challenges that you have with your software architecture right now. Thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.